Hello and welcome to today's Lux Research webinar. We will begin in just a few minutes as attendees are still logging on. Hello and welcome to today's Lux Research webinar. We will begin in just a few. Welcome to today's Lux Research webinar. The focus today will be on Materials 2030, building a digital bridge to tomorrow's business model. My name is Kevin C. I'm VP of Digital Products at Lux, and I'll be hosting the webinar today. And I'd like to introduce our speaker, Anthony Schiavo, who's an analyst at Lux Research. Throughout the webinar, you can type any questions you have in the question and answer box on your screen. Time permitting, we will answer as many questions as we can. If your question does not get answered, please don't hesitate to email it to questions@luxresearchinc.com, and we will respond via email. All attendee phones will be on mute to minimize background noise. And now I'd like to introduce Anthony Schiavo.
Thank you, Kevin, and thank you for everyone for joining us today. Before we get into the webinar, I would just like to take a moment to highlight some of our recently published and upcoming research. For all of our accelerating materials innovation clients, we did recently publish a report detailing the top material developments in 2017 and highlighting some trends for 2018. And we're also working on a adhesives innovation landscape, trying to understand the pain points, the key drivers, and the technologies in that space. So as Kevin mentioned, today we're going to be talking about the future of materials and chemicals, and really how digital tools and technologies will begin to transform the business model. So first, I'd like to talk about the pressure that faces the materials and chemicals industry. Secondly, I want to talk about how 4 key digital technologies can meet those pressures. And then we'll begin to talk about how those can transform the business model. So first, materials and chemicals industry under pressure. The first pressure is commoditization. Now, Webster defines commoditization as the process by which a good or service becomes interchangeable with one provided by a different company. This can be the result of new technologies, new competition, new business models. And really what it means is that there's a loss of differentiation and typically a loss of margins. And this can happen both to more advanced materials like coatings, as well as very basic materials like sugar. Secondly, we're really seeing a pickup in mega mergers, large groups joining together, whether it's Bayer Monsanto, ChemChina Syngenta, or Dow DuPont. These super companies have serious levels of scale, and this allows them to operate very efficiently. If you're on the outside looking in, you need a way to be able to compete with those benefits of scale. Third, we're really seeing consumers become very aware of the types of materials and chemicals that are in the products around them and in what they're consuming. One example that hits close to home to my Boston-based colleagues is that Dunkin' Donuts had to remove the titanium dioxide from the powdered sugar in their donuts. Similarly, headlines like "What is BPA and why is it bad for you?" really drive home the perception of chemicals in the broader public. So there's really, this creates a risk that you may have to change what you're selling or what you're manufacturing, or what you're putting in your product. Speaking of risk, we're also seeing an increasing risk for volatility in petrochemical feedstocks. And this is related to falling and flattening demand. This is a chart that we put together on the relative amount of demand for transportation feedstocks. And what you can see is that past 2030, it really begins to drop off. And this can create both uncertainty in terms of availability, as well as in terms of the price of these petrochemical feedstocks, as the production of those is so tightly tied to the production of gasoline and diesel for the transportation industry. And lastly, blockbuster innovations that create new markets or whole new product classes, are really becoming more and more infrequent. The types of materials that we've looked at as blockbuster innovations, like graphene or carbon nanotubes, in the past 20 years, haven't really panned out in terms of creating large markets. Lux, really sees these as combining for less than $1 billion in terms of market size, which is way too small to move the needle for the materials and chemicals industry. So, we're seemingly moving away from an era of inventing, new nylon. So how can materials and chemicals companies respond to these pressures to be more efficient, to meet commoditization, and to reduce risk? So we've seen the pressures, and now let's dive into these digital technologies. Lux uses a framework we call the digital toolbox, which encompasses a wide range of different tools that companies can use and deploy. This is certainly not an exhaustive list of digital technologies. And today, we're just going to be focusing in on these four that I think are really specific for the materials and chemicals industry. That's materials informatics, industrial Internet of Things, digital synthetic biology, and digital sales platforms. So materials informatics. This combines machine learning and advanced statistical methods to really accelerate the process of R&D. It can be used in materials discovery, materials optimization, and the design of materials and products. So this really has the effect of essentially reducing the amount of laboratory testing that's needed and shortening the timeline of developing a new material, formulation, or product. We're already seeing adoption. This consortia of Japanese chemical companies recently announced that they were building a shared data platform with the express purpose of using that platform for materials informatics. We've already seen the first successful case studies of this technology as well. Cooper Standard partnered with Uncountable, and they used materials informatics specifically for formulation development. Uncountable was able to take their needed properties and suggest formulations, and they were able to essentially cut their R&D time in half by suggesting a formulation that met their needs. And so this really helps smaller organizations operate more efficiently, make their R&D budget go further, and bring their products to market faster. Secondly, IIoT. This is a very broad term, but really, on the most basic level, it encompasses data creation, typically through sensing, data transmission, and then the use of that data for analytics to help guide decision-making. This is something that we have a number of different reports on within our digital transformation practice. But I really want to focus in on two use cases within the materials and chemicals industry that are already increasingly mature. The first example here is BASF uses a combination of sensing throughout their Ludwigshafen facility, and that enables superior prediction of steam and energy demand. This allows them to operate their existing production facilities in a way that's much more efficient than before. But it's not just a production technology. AkzoNobel partnered with E2Open for supply chain IoT. So their products that AkzoNobel produces are actually sending data back to AkzoNobel, and this allows them to improve the accuracy of their demand forecasts by around 30 to 40%. So they're able to operate more efficiently in terms of knowing what they need to produce, and they're able to reduce their risk in terms of misunderstanding the demand. Third, digital synthetic biology. And this one's interesting because it's really a combination of technologies. Fermentation processes by which microbes are used to create chemicals, combined with automation and computational tools that really speeds up the process of designing those microbes with specific DNA and testing the scale up and production of the chemicals with the fermentation process. And this creates a platform for the production of flavors, fragrances, and specialty chemicals. We're already seeing startups like Zymergen and Ginkgo Bioworks begin to penetrate the market and have some initial success. But what I think is really telling is that many of these companies are now positioning themselves as partners. And that's because the flexibility of digital synthetic biology is really its key attribute. With this, chemical companies can potentially have one platform and one piece of infrastructure that can produce a wide range of different chemicals and specialties based on what the market needs. And this really helps both reduce costs in a direct way. Often producing through fermentation is cheaper than a natural method. But it also helps reduce the capital cost of building that infrastructure, and also helps hedge against risk because you have a very flexible system. And lastly, digital sales platforms. Now, we often think about digital sales or e-commerce in the context of consumer with platforms like Amazon or eBay. But in reality, it's also very mature within the materials and chemicals industry. You have platforms like Diameter from Dow Corning, which is an online sales platform that was founded in 2002. What's changing, however, is that these digital platforms are really beginning to integrate decision-making support tools and go far beyond just a sales channel or a marketplace. So there's startups doing this. Farmers Business Network is one. They take farmer shared data on agrochemicals and also on the conditions of the crops, the yield, the weather, and they combine all that to allow farmers to make better decisions about what types of chemicals they want to buy. Similarly, BASF and just about every other major agrochemicals company is offering a wide range of decision support services. In this example, it's forecasting, weather forecasting. And this helps support their herbicide sales by really enabling their customers to know when it's going to be most effective. And this technology really has the potential to combat commoditization. Even if your material or chemical is identical to your competitors, the digital support tool, decision support tools that you have, and the digital platform that you have for buying can create a reason for an end user to buy from you compared to buying from a competitor. So I hope we've seen that how these tools can really begin to meet these challenges of efficiency, of risk, of commoditization. And in the near term, I think the challenge will be to understand which tools make the most sense for your business and deploy them in a targeted way. That's something that Lux can help with. But I think taken together, they can really begin to transform how the industry operates. And that's what I'd like to talk about now, this new materials business model. So the current materials and chemicals business model has a bit of a split. For many materials, especially polymers, there's a commodity and a specialty model. And some companies like Dow have maintained both commodity and specialty businesses for the same material, in this case, silicones. Now, Lux built a digital business model framework that takes the customer journeys and different attributes into account, as well as 4 key dimensions. Today, I'm just going to focus in on dimensions, but we do have both a full report on this topic as well as a webinar. So if you're interested in diving deeper into the digital business model framework, I absolutely encourage you to check out those reports. Those 4 dimensions that we're going to be considering today are time, the time of the transaction, money, especially the additional cost of any sort of friction within that transaction, risk in terms of both the price as well as risk of a consumer going elsewhere, And lastly, the customer experience. So let's look at the commodities and specialties. Well, within commodities, they do very well on time as products are largely kept in stock. And there's a very low cost of sale. Groups like Dow Corning were very successful in lowering their cost of sale. However, there's risk. Volatility in terms of the price is a major concern, and we've seen that affect margins both positively and frequently negatively across a wide range of commodities. And additionally, the customer experience is relatively poor. You don't have the type of sales support or customization that you might get in a specialties model. In specialties, however, the time aspect is not as good. If you're developing a custom product or even working with a dedicated technical sales team, that takes time. Similarly, there's a high cost of sale because you do have a lot more typically dedicated resources in terms of R&D support, sales support, and that just adds to the cost of sale. The benefit, however, is while pricing might be higher, typically specialties are sold on a value-based pricing. Both groups essentially agree to a price that they're willing to be paid for the material. And this helps really prevent the volatility that we see with commodity market-driven pricing. Similarly, the customer experience is much better. They're able to get a more customized product that really meets their needs, and they're able to work with a team to do that. So how can we create a best of both worlds business model? Well, let's see how these digital tools really begin to affect these business model dimensions. Materials informatics is really all about time and cost, enabling high-speed, low-cost product development. And it does so through a digital channel. IoT, similarly, looks at cost and risk, helps reduce the cost and the risk by enabling better planning. Digital synthetic biology can lower the cost of the capital and also help keep the production more flexible. And that really helps, again, with the cost and risk. And digital sales platforms really have the opportunity to affect all of these attributes, and especially by bringing those decision support tools to the end user. And what these tools do and what this digital sales platform will enable is essentially a more unified model as the cost of customization goes down and the speed at which customization can occur. So in this unified model, there'll be powerful decision support tools such as materials informatics and some of the selection tools we saw earlier. And that's going to make it much faster to make complex decisions about what materials, and also faster to develop the materials. As I said, the cost of customization will come down, being driven by reduced cost of R&D and reduced cost of sale. There'll be less risk as the value of the model overall will drive the pricing. So what I mean by that is, rather than being simply dictated by the price of the market, there'll be additional premiums for the value of the customization and the value derived by the actual decision support tools as well. Those will all be amortized through a price that will be less subject to market-driven fluctuations. And through the digital platforms, end users will be able to find the right level of customization. Not every end user needs a highly specialized product. Commodity polymers, commodity products work for a very large number of groups. But essentially, taken together, these tools and these models will make it much simpler to sell commodities, more like specialties, with an extra layer of customization added on at a relatively minimal cost. And it'll make specialties much more easily. It'll make it easy to sell specialties like commodities through simple, fast, largely digitally driven sales channels, essentially pushing each type of material towards a single unified model. So what can you take away from this talk? Well, I think the first thing is, one, adopt these technologies in the near term. There's still a lot of opportunity to just get improvements in efficiency, improvements in your R&D process, improvements in your sales process. And even though some of these technologies are more mature than others, they're still far from fully adopted or universal in the industry. So there's definitely an opportunity to be a leader here. Secondly, begin to understand your materials future business model. These changes are not going to be happening with every single type of material. Some commodities are just fully, don't benefit from customization at all. Some specialties are very highly specialized. But for materials on the verge of commoditization that are already experiencing a business model change, they might end up in a business model that looks more like a unified model than a traditional commodities model. And lastly, I encourage you to re-examine your organization's skills across all different roles. These changes are coming not just to R&D, but R&D, production, sales. So it really is going to affect the entire organization. And the benefits will be greatest if the entire organization works together on this transformation. So I just want to thank you again for your time. We will be providing a link to the webinar, and we'll now take any questions from the audience.
Thank you, Anthony. We'll now be taking questions that you may have on the webinar, which you can type again into the questions box on your screen. Please don't use the chat box for questions. If we don't get to your question on this call, please contact questions@luxresearchinc.com after the webinar, and we will route your question appropriately. And with that, Anthony, we have a few questions already coming in. The first one is relevant to materials informatics, and specifically, how can we start building the skills needed to use materials informatics?
That's a great question. What I would say is typically we're seeing groups start with a really focused engagement. The business models around materials informatics are definitely still being developed. So a lot of groups are working sort of via a consultancy model. And I would say start with both a specific material and product and also a specific buyer or end user, so that you can really build that skill set in a very narrow way at first, and choose one, not maybe based on your most important product, but the product where you have the most data to really do a robust materials informatics system.
Thank you. The next question is about how you actually access these digital platforms that you discussed, and specifically, should we build or should we buy these digital platforms?
So that's a pretty complicated question, and it's one that I think you actually did a great talk on, Kevin. But the short version is, I think for the chemicals industry, I would recommend, partnering or buying. I don't think that, for these digital sales platforms, it is, when we look at like the agriculture space, for example, that's where there's been a lot of acquisition activity with groups adding in the capability like BASF, Monsanto, buying up these essentially, these weather forecasting groups and other groups. So I think that that's just the easiest and the most straightforward from a skills development and from a business standpoint. There are a lot of really strong providers out there, so it's not really worth trying to reinvent the wheel. Great,
and I do have a question from an attendee, maybe looking for clarification on the business model discussion, and specifically why the cost would go down for customers if they get a customized solution in this unified model. And I think if you could speak to the perspective of that framework, how it's mostly coming from the vendor perspective, I think you were saying, but if you could kind of clarify the benefit to the vendor versus the benefit to the customer.
Yeah, absolutely. So the benefit from the customer, and specifically in cost reduction, we would likely see that mostly from the side of specialties products. So if you wanted to develop a specialty product, that the cost of sale and the cost of R&D should be lower there, and that should hopefully be passed along to the end user, in a competitive environment. In overall, for commodities, I don't expect a substantial increase in cost, but I think that the costs will hopefully become less volatile as the pricing. I think obviously there's going to be, if there's feedstock fluctuations and other things that are driving price, external factors driving price, those are still going to affect the price. But within the business model itself, I think that there's a little bit more of a value-driven buying decisions that can be made, hopefully, basically sticking with certain sellers because of the value of using their predictive tools, the value of using their sales platform, the value of using their customization. That will drive people to, I think, stick to a certain vendor, even if the cost is slightly higher.
Thanks, Anthony. The next question is about some details on the Japanese Consortium for Materials Informatics, and if you can provide more details on the approach, what the different players are doing, and how they intend to use Materials Informatics.
Yeah, that's a great question. So at this stage, I think one of the questions we get asked frequently is, will chemical companies share data with their competitors to use materials informatics? Materials informatics needs ideally as much data as possible. So right now, this consortia is really focused on the data sharing and the data platform. So these groups have essentially committed to pooling some but not all of their data in terms of essentially test results on processing, structure, and properties on a handful of polymers that they're all interested in, major classes like urethanes. And over the next 2 years, I think the goal is really just to build the data platform. So I would say right now it's much more what they actually tend to do with the materials informatics. It's not quite clear to me, or they haven't quite said, other than that they intend to use this for materials informatics. But to me, it's important just from the element of we have a bit of a initial answer in terms of, are groups going to be willing to enable some sort of data sharing to actually accelerate and enhance their ability to perform materials informatics. I would imagine they're probably going to be looking at formulation development, just based on, I think that's the most powerful use within the polymer classes, but that really remains to be seen.
Thank you, Anthony. The next question is about some of the barriers to adoption, and specifically that a lot of the firms in this space are SMEs and often have less capacity to adopt new technologies like those you've outlined and to change their business model. What would you recommend for these types of SME businesses to take some of what you're talking about today and put it into action?
So I think SMEs are actually one of the groups that are kind of well positioned here, or at least not as poorly positioned. With these digital technologies, the big advantage of them is that, they're not as capital intensive. We're not talking about, building whole new refineries or production facilities. A lot of this customization element that I'm talking about can be handled, I think, on the level of formulation. And there's a lot of SMEs already doing toll formulation, custom formulation. And those groups are essentially going to benefit by potentially being able to plug into a broader sales platform. I mean, I've heard a lot of different groups trying to or talking about an Amazon for chemicals. That's certainly far from reality, but there are groups working on it. There's a startup Node, and that's I think it's spelled kind of in a strange way, but that group is essentially creating one online platform for essentially products and sales, right, of chemicals. So I think these, in terms of materials informatics and some of the IoT solutions, these are relatively low cost to adopt internally for manufacturing. Similarly, the digital synthetic biology, I think these SMEs can partner with these digital synthetic biology players. And in terms of the sales channels, I think they're the ones who could benefit substantially.
Okay, the next question's a big one that I think internally to Lux we are thinking about quite a bit, but specifically the question is how digitalization will affect the R&D community in general, and what steps should be taken to prepare for that?
Yeah, that's a great question, and that's one I have been thinking about, and I know we've had a lot of discussions on that topic. I think that it will. The first near-term change is a skill set change. The ability to interact with how these tools, right? That's the first change. And I also think that we'll begin to see the actual processes change somewhat. For example, the types of data that you need to feed a materials informatics system is slightly different than what you need to sort of do R&D the traditional way. For example, data on failed experiments is just as valuable, maybe even more valuable to materials informatics tools as data on successful experiments. So how groups actually test, how groups actually design experiments, plan their R&D, I think that will eventually begin to change as well, or change relatively in the near term, as they begin to shape that more to really leverage these tools as they get better understanding and better integration into the workflow. In the long term, I think there is some level of automation, that's going to take place. How that will really affect, the R&D groups within companies, I'm not sure.
Yeah. And just to add to that, from some of the work we've been doing internally, Anthony, you talked about materials informatics, which in practice can help you, for example, help you in the research process to find more different new materials more efficiently and faster. So there's the research process itself. There's also, if you've seen some of our previous work on things like the tech signal and our 18 for 18 is prioritization of what to research. So data not only plays a role in the process of R&D, but also how you prioritize the technologies you work on, how you decide what to keep and what to kill. So we see that becoming a much more integral part of actual R&D planning, as Anthony said. So just to piggyback off of the kind of tactical examples of finding a new material versus actually helping you figure out what to work on, I think those are kind of two different levels where digitalization will impact.
Yeah, and just to actually build on that, we saw a recent example of, I believe, Mitsubishi Chemical building a unified data platform across a few of the companies they had acquired. And one of the features that they're putting in that data platform is a social feature, which will actually allow their researchers to like and share and promote, exciting or topical research within their company. So we're already beginning to see, they're still building that data platform, and I think it's going to be live early next year, but we are already beginning to see these digital tools sort of affect, even just internally or outside of informatics, really begin to affect the decision-making processes.
Great, and we have time for a couple more questions. The first one is, do you see the greatest opportunity in helping move commodities towards specialties or vice versa?
I think I see the greatest opportunity in helping commodities move towards specialties. I say that for two reasons. One, I think that just occupies a large share or a larger fraction of the market. And two, I think that is a little bit more disruptive in terms of a change. For specialties, I really see the transition as being taking a lot of things that were already happening and streamlining them, making them really efficient, and making them happen with less human interaction, and over a digital channel. Whereas commodities, it's actually a move, it's more of a step towards more customization. So I see that as being the bigger change and the bigger opportunity.
Okay, and we'll wrap up with one final question, and that's, what's the timeline for adoption of these technologies you've talked about in the toolbox, as well as timing for some of these broader shifts in business model?
Yeah, that's a good question. I think timeline for adoption of these technologies, it depends. Some like IoT, we're already seeing, scaled deployments. I would say generally over the next 2 years, I expect a lot of these to be deployed. Even the one that's furthest out is probably the sales platforms. Although we're already seeing that in agrochemicals, that's relatively mature. We're seeing startups, the first startups like Node developing these platforms. Some of the digital sales channels are already very mature for commodities. So it is fragmented, I would say. But over the next 2 years to 5 years, depending.
Okay.
For the longer transformations, I think you're looking more like 5 to 10 years, and then maybe beyond 10 years. But I would say for the sweet spot, which I think is really in polymers in particular, I think 5 years we'll really start to see the first emergence of these new models.
Thanks a lot, Anthony. So we're going to wrap up the webinar now. If we did not answer your question today during the webinar, we will be in touch shortly. So that concludes the webinar for today. The slides from the webinar will be available to all attendees within 48 hours. And once again, if you have any questions, please email us at questions@luxresearchinc.com or contact your favorite client contact on our side, and we'll be back with you soon. Thanks for joining.